In this video, we're going to be looking at theoretical probabilities and how we calculate outcomes from a probability tree. So in this example, we have someone winning a game. The chances of that happening is 7 out of 10. And so we can work out lose by subtracting from 1. This is in our previous video, so you can refer to that if you're not too sure. And then win, we're going to assume that they're the same in these outcomes here. So lose 3 out of 10 and lose equals 3 out of 10. Okay, so we have to calculate the theoretical probability of winning both games. Win-win, we just take 7 out of 10 and 7 out of 10 and we multiply them together. Okay, so as you go along the branches, you multiply. That's the rule. So 7 times 7 over 10 times 10. Okay. If we were to do lose-lose, then it would be 3 out of 10 times 3 out of 10. And that would be 9 over 100. 3 times 3 over 10 times 10. What about if they ask you the chances of winning 1 out of the 2 games? Okay, when we highlight the branches that are relevant, winning 1 game would mean that you could win and then lose, or you could lose and then win. So there's actually 2 possible branches that will give us the answer that we need. So we're going to calculate those separately and just add them together at the end. So win-lose would be 7 out of 10 times 3 out of 10. That is 21 out of 10. And lose and then win, 3 out of 10 times 7 out of 10. That's also 21 out of 10. 21 out of 100. 21 out of 100 for that one there. 10 times 10 is 100. So when you're doing this, they don't always come out the same like that. That doesn't always happen. It sometimes does. But we're calculating the 3 out of 10 times 7 out of 10 in this case. Now we need to add these 2 together because these 2 branches are the ones that we want. And this is where a lot of confusion happens because students try to add as they go along the branch, but that will put you over 100% or 1. Okay, so we multiply as we go along, and then if we need multiple branches, we add them at the end. So 21 over 100 plus 21 over 100, they have the same denominator, so 42 out of 100. And we can cancel that down, etc. But the main point is we're adding the 2 branches that we actually need. Okay, now one final thing about this, as we develop this understanding and we're going for maybe the higher levels, they might ask you at least 1 win. Okay, at least 1 win. So to win at least once, we could have the 2 branches that we've already calculated because they won and then they lost, or they lost and they won, so they've won at least 1 game there. Or we could have the top branch as well. Winning both games is winning at least 1 of them. So in that case, we would include this as well. Okay. And we've calculated like 3 branches there. It's not like the biggest deal, like that won't take a huge amount of time. But like I say, as we're progressing and looking at the higher level questions, which is, they'll be almost exactly like this, but there'll be a lot more branches in there. We want to think about a more efficient way of doing it. Like imagine this branch, this tree had like 27 branches in it, and you had to calculate 26 of them. That would be a lot of work. So it's a lot more efficient to look at what's the opposite of winning at least 1 game. The opposite of winning at least 1 would be to lose both. Okay, so to be more efficient, we could just calculate the 1 branch that we don't want and take that away from 1, because we know that all probabilities have to add up to 1. So 21 over 100, 21 over 100 and 49 over 100, if I add those together, would be 91 over 100. Or I could calculate the one I don't want and subtract that from 1. Okay, so 1 minus 9 over 100 gives you this. Okay, so it's just an exam technique that if you find yourself looking at a probability tree and getting overwhelmed by the number of branches you might have to calculate, have a think about doing the opposite and subtracting it from 1.